10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Allumage de ESR et décollage. La propulsion est nominale. Pilotage calme.
We have lifted off. Ariane 6 and CSO-3 have started their
Propulsion
journey.
nominale.
He's telling us that the propulsion is normal. We are looking here at our cameras, onboard cameras.
Tous les paramètres à bord sont nominaux.
He's telling us that everything is going normally. I believe, David, we're looking down here at one of the boosters.
Yes, that's right. These are the onboard cameras. We have a
Propulsion
cloudy day
nominale.
today, so you can see the rocket going through the clouds.
Indeed, we've already broken the sound barrier.
Pilotage calme, trajectoire nominale, paramètres à bord nominaux.
He's telling us that everything's going according to plan. David, we can hear our rocket coming over the Jupiter Mission Control Center about 16 kilometers from that pad. It takes time for the noise to get to us, the rumble, as it's sometimes known in the jungle.
That's right, and we can feel now the vibrations of the boosters coming up to us 15
propulsion est
kilometers
nominale.
away.
Indeed, and it's those boosters which are doing all the work, even though we have switched on the engine on the Vulcan engine on the main stage. The boosters, well, their job is to literally boost us away from our
Trajectoire
planet's
nominale,
gravity.
paramètres à bord nominaux.
That's right. It's the boosters are providing more than 85% of the more than 800 tons that we need to take off, and these boosters will burn its 2 times 142 tons of
Pilotage calme.
propellant during a bit more than 2 minutes. And after that, we will have lost about 70% of the mass that we had at the time of liftoff.
That's the name of the game. The lighter we are, of course, the faster we go. Those boosters scheduled to
Propulsion
detach
nominale.
in a matter of seconds. Seeing our images here on the live cameras
Séparation des ESR.
just a few seconds after the event, but we have confirmation that those have actually separated. As I
Propulsion
said,
nominale.
the images are coming to us for technical reasons, just with a very slight delay. And he's telling us that the propulsion is nominal. And there we go. That's what it looks like in space. Those boosters falling away. The trajectory on the right-hand side of our screen.
Trajectoire nominale, paramètres à bord sont nominaux.
Everything's normal. The green line is the planned trajectory. The cross, indeed, is our actual position of our rocket. Our speed and altitude, David?
Yes, we're close to 100 kilometers now, and we're 150
La propulsion
kilometers
est nominale.
downrange from Kourou, and we have a speed now of 1.7 kilometers per second and increasing.
Per second, not per
second.
hour, per second. So that's the kind of speeds we're going to be heading up towards. We'll be getting to 8 kilometers per second. Look at the images on the bottom right of your screen. That is the big main stage, the tank of fuel at the very front of sort of pointy section, if you like, is our fairing with our satellite inside. It's got a number of different jobs. It's protecting the satellite, isn't it?
Right, it protects the satellite while it's on the ground against dust, humidity, and any kind of pollution. Then it protects the satellite during the launch itself, the liftoff, because there is a lot of acoustic noise.
Trajectoire nominale.
And finally, during the atmosphere part, then it protects it against the air friction and the extreme heat that is generated by this friction.
So our satellite nice and comfortable up there in first class inside the fairing, having started its journey. That fairing will remain there for another few seconds. And of course, as we saw earlier, David, you were explaining it's made in 2 halves.
That's right, and this is the onboard camera showing the 2 halves of the fairing that will separate.
Séparation coiffe.
We have confirmation that the fairing has separated, and we'll be seeing those, hopefully, those images on our onboard camera. It actually, as it separates, David, it flexes. It's called the breathing mode. It's very specially designed to do that.
Yes, that's right. The breathing mode. Here we go. We have the separation and the breathing mode through the onboard cameras. This breathing mode is this movement of the two halves that happens due to the forces of the pyrotechnic separation and then the ejection forces and the flexibility of the structure.
Looking back down at our planet now, you can see that thin blue line.
La propulsion est nominale.
The atmosphere of our Earth. He's telling us that the propulsion's normal, everything's going according to plan. So we're burning the main stage. It's a great big tank of fuel. David, tell us a little bit about it.
Yes, so the main stage is a cryogenic stage. It's 32 meters tall and about 5 meter diameter. It weighs 23 tons and burns 154 tons of cryogenic propellant. And it has two tanks, a hydrogen tank in the lower part, an oxygen tank in the upper part. And for those who remember, on Ariane 5 we had a common bulkhead, meaning that the two tanks were together. On Ariane 6 they are separate. This in order to improve the handling of the pressures in the tanks.
Propulsion nominale.
And in the lower part of the tanks, we have the Vulcan 2.1, which is an improved version of the Vulcan 2 engine that we had on Ariane 5. We have improved the nozzle manufacturing. We have gas generators which are made using additive manufacturing, and we have also added a thermal protection around the nozzle in order to protect it from the heat coming from the boosters. And this will burn for over 7 minutes, increasing speed and altitude.
Separating each section of the rocket looks simple, but of course a lot is actually happening up there, and we're getting closer now to the next main event, which will be cut off of that main engine.
Yes, that's right. It's the guidance algorithm that's on the onboard computer that will detect that we have reached the right orbit for separation, and then it will send the shutdown command to the Vulcan engine. After that, we will have a pyrotechnic separation between the two stages and a set of springs that will push away the two stages. And we should be able to see it on the onboard cameras.
You can see on the bottom right is you can see our satellite CSO3 attached to the front of the rocket, at the top of the rocket. Getting close now to the next event. We call it MECO, main engine cutoff.
Extinction Vulcain.
And we have confirmation that the engine has switched off.
Séparation LLPM.
And we have confirmation that the main stage
Allumage Vinci. Fin de mission sauvegarde.
Has separated, and the upper stage has switched its engine on, and that's what it looks like up there in space with our onboard cameras. That great big
Propulsion nominale.
Of propellant. It's burnt its fuel. It's falling back down to Earth. So, David, the upper stage has taken the wheel. It's a little bit like a fancy orbital taxi driver, because its job is to drop off its passengers in space. Today we just have one passenger. And we've got a new engine for the upper stage. It's called the Vinci engine.
Yes, the Vinci engine is one of the big innovations of Ariane 6. It provides the mission flexibility. It is designed to switch on and off up to 4 times, allowing to take different passengers to different orbits. It's the first Ariane rocket that has a cryogenic engine with this ignition capability. For the mission today, we will use the engine twice to deliver CSO3 to its orbit. And after that, we will use a third burn of the engine to deorbit the upper stage.
And we had the range operations manager just back there announce that we've switched on something called the APU, the auxiliary propulsion unit. It's a new device that we've got on the upper stage. It performs a number of critical functions to enhance the versatility of Ariane 6. Everything's going normally. We'll talk a bit more about that, David, later in the programme, so do stay tuned. But just before we do, a shout-out for the Franco-German cooperation on the upper stage.
Yes, the upper stage, which is designed and built by Ariane Group in Bremen, in Germany, with an engine designed in Vernon, in France. And the whole thing was tested during the development of the launcher in a test bench designed by the German Space Agency.
And we picked up the signal in Bermuda. So once we release CSO3, the French Space Agency will take on their satellite.
Agence spatiale française, assure par délégation de la Direction générale de l'armement la maîtrise d'ouvrage du projet CSO. Cela va de la conception du système satellite jusqu'à sa mise en orbite et son exploitation opérationnelle pendant toute sa durée.
La trajectoire est nominale, tous les
Nous
paramètres à bord sont
appuyons sur des
nominaux.
compétences métiers pointues et un savoir-faire reconnu depuis 35 ans. C'est au CNES que sont opérés quotidiennement les satellites afin de programmer les prises de vue commandées par la Direction du renseignement militaire.
Le CNES vient de recevoir les listes de programmation à envoyer au satellite CSO. L'équipe mission a préparé les automatismes permettant de transformer les listes reçues en ordre élémentaire pour chacun des satellites. Les ingénieurs mission surveillent le bon déroulement des activités pour intervenir en cas de problème et ainsi maintenir un très haut niveau de disponibilité du système pour les utilisateurs. Les télécommandes sont prêtes. Pendant ce temps, l'équipe bord veille au grain. Son rôle, assurer la bonne santé des satellites. Elle réalise des activités permettant d'anticiper les problèmes sur les satellites afin de garantir leur fonctionnement et une disponibilité maximale pour les utilisateurs. En cas d'anomalie, elle mène les investigations pour identifier la cause et réaliser les opérations de remise en condition opérationnelle du satellite. En parallèle, l'équipe dynamique de vol vérifie les résultats de la détermination d'orbite qui calcule la trajectoire réelle du satellite. Si celle-ci s'éloigne trop de l'orbite nominale, alors l'équipe programme une manœuvre de correction d'orbite. La trajectoire réelle est utilisée pour surveiller les rapprochements avec les autres objets spatiaux. En cas de risque de collision, l'équipe programme une manœuvre d'évitement. Cette trajectoire est également utilisée pour piloter les stations au sol et la programmation des prises de vue. L'équipe sol est responsable du bon fonctionnement des moyens matériels et logiciels du centre de contrôle pour l'ensemble des métiers.
La propulsion est nominale.
La surveillance quotidienne des systèmes informatiques permet d'intervenir au plus vite dès qu'un incident est détecté. La moindre défaillance est traquée et corrigée en un temps record. Elle apporte également son expertise aux autres équipes pour tout besoin d'évolution de leur logiciel. Puis vient le moment
nominale, les paramètres à bord sont
Depuis
nominaux.
le centre d'opération du réseau CORE, les antennes prennent le relais. C'est le point névralgique à partir duquel elles sont pilotées pour émettre des télécommandes et recevoir les télémesures. La station d'Ossa Galicius est désormais connectée au satellite CSO en visibilité. Retour au CPCC. Maintenant que le satellite est connecté et positionné sur son orbite mission, le contrôleur supervise le bon déroulement des dernières activités. Tout se déroule comme prévu. Les télécommandes sont envoyées. La direction du renseignement militaire réceptionne les images à usage défense et les exploite pour assurer la sécurité du territoire. Quant aux images techniques, elles descendent vers le centre d'expertise pour être traitées par l'équipe qualité image. Radiométrie, géométrie et résolution des images sont affinées. Les images deviennent optimales. Ces performances seront suivies durant toute la durée de vie des satellites. Grâce à CSO3, le troisième et dernier satellite CSO et ses nouvelles capacités, la précision atteint de nouveaux sommets. Images plus nettes, délai réduit, capacité décuplée, un atout stratégique inestimable pour la défense. Mission accomplie pour les équipes CSO du CNES.
La propulsion est nominale.
14 minutes into the flight, the rocket talks to us as it flies over. It communicates with the tracking stations. They collect the data and they send it here to what we call the CVI, or the Quick Look Telemetry team, who are at the Guiana Space Center. There they are, bottom right-hand side. He's telling us that everything's going normally, the range operations manager. There they are. David, what are they doing?
So yes, they are collecting the real-time data that the launcher is sending. This includes the status of the engine, the trajectory, the flight control, and they compare this live data from the rocket to what has been predicted. So this allows them to continuously analyze the launcher's behavior and to confirm that it is as expected.
Now, lots of people working across Europe on the rocket and the satellite. Let's hear from some of the teams.
Trajectoire nominale, paramètres à bord nominaux.
Moi, je suis le Launch Campaign Operation Manager, donc le chef des opérations de lancement sur la campagne VA263. Fred est mon député sur cette campagne, mais ça n'a pas toujours été le cas.
Sur le premier vol Ariane 6, qui était le vol inaugural, qu'on appelait aussi FM1, j'étais Elcom sur la campagne et Nicolas était mon député.
Ce qu'il faut voir, c'est qu'on va échanger nos fonctions pendant tout le début de la phase IOC, l'Intermediate Operational Capability, de manière à ce que chaque fois l'un soit en titre et l'autre soit en député, et fasse en sorte qu'on profite de la campagne en cours pour déjà préparer tout l'après et déjà préparer les optimisations et les réductions du cycle opérationnel de campagne en campagne. Voilà, donc c'est ça l'enjeu de cette phase un peu particulière qui est le début de la phase d'exploitation.
L'idée en fait d'être deux aussi sur Sénat, c'est des formes de continuité,
Trajectoire conforme à attendu,
du pilotage,
nominaux.
dans l'amélioration de nos process de pilotage, de notre organisation, mais aussi de notre montée en compétences et en maturité technique. Donc on a besoin aussi de ça, de cette continuité sur chaque vol, parce que le système en fait il est jeune aujourd'hui, donc on est en train de le faire grandir et il est évolutif et on a besoin d'être à deux pour assurer cette continuité de manière efficace et de manière dynamique.
Donc, mon métier de directeur de mission satellite consiste à vérifier au préalable que le satellite est compatible du lanceur, donc des environnements à la fois mécaniques, électroniques, électromagnétiques, environnementaux, acoustiques, un large panel de métiers et de technicité pour valider la bonne interface et compatibilité du satellite avec le lanceur. Ici en Guyane, mon rôle de directeur de mission satellite consiste avec Arianespace à piloter la campagne de lancement du satellite jusqu'à la chronologie finale et la mise à poste par le lanceur.
Je travaille sur le projet depuis 2006. J'ai commencé par le pilotage des satellites. Ensuite, je me suis occupée de qualité image. J'ai bifurqué vers le suivi de l'instrument, donc de la charge utile fabriquée par Thales Arianespace. Et depuis 2021, je suis responsable de l'ensemble du programme pour Airbus. Sur un projet de cette envergure, des centaines de personnes ont contribué de la phase de conception à la phase de développement puis de fabrication et finalement de tests, et tout ça dans nos locaux à Toulouse.
Le développement de l'instrument et de ses équipements a été réalisé par des équipes Thales Arianespace très expérimentées. Pour beaucoup, elles ont déjà travaillé sur Helios 1, Helios 2, Pléiade. Toutes les activités sont réalisées sur les sites de Thales Arianespace de Cannes, Toulouse, Aix-en-Provence pour Thales CESO. Nous avons actuellement une équipe qui est présente sur le site du CNES à Toulouse pour participer à la mise à poste et aller jusqu'à aux premières prises de vue visibles et infrarouges de notre instrument.
Pour Arianespace, je suis responsable production des adaptateurs. C'est une pièce mécanique qui sert d'interface entre le satellite et le lanceur. Mon travail consiste aussi à apporter une expertise technique lors des opérations d'intégration du satellite sur l'adaptateur et sur le lanceur, et ce, dans le but de garantir la bonne intégration du satellite sur le lanceur, son aptitude de vol, jusqu'à sa séparation. Ce qui est passionnant dans mon métier, c'est que je joue en fait le rôle d'adaptateur entre le monde du lanceur Ariane Group et le monde du satellite avec notre client CNES et le constructeur du satellite Airbus. Avec mes collègues d'Arianespace, notre travail est de faire rencontrer ces deux mondes pour garantir le succès de la mission.
Oh, incredible. David, they're your colleagues. It must
be colleagues and customers both working hand in hand to make this a success.
Indeed, I think everyone can feel very proud. Right, coming up to the next major event, that will be the switching off of the Vinci engine. That's what it looks like. It's burning at the moment and has about 5 seconds left on the burn.
Première extinction Vinci.
And we have confirmation there that the engine has indeed switched off. So, the first major step now in reaching the desired orbit. We're coasting effectively now, David, without the engine. Why did we switch it off now?
Yes, well, it's a bit like a roller coaster. We have picked up speed. You can see on the curve that we have decreased a bit the altitude, and we have been picking up speed also because the Ariane 6 has been pushing us for over 20 minutes now. And we are at the bottom, and we will be climbing up using the speed that we have. In physical terms, we will be transforming the kinetic energy that the launcher has been giving us into potential energy, climbing higher.
We've got a question coming in on YouTube. Paul Graves is asking, was the air conditioning inside the fairing to keep the payload healthy?
Yes, the answer is yes, of course, while the satellite is sitting on the ground under the fairing, because we have heat and humidity here in French Guiana. We have constantly providing air conditioning to the satellite to keep it at the temperature that they require.
We're flying around at the moment on what we call an elliptical orbit. It's the shape of an oval. Imagine the Earth at one end of the oval, and our spacecraft, our rocket is effectively slingshotting close to Earth and then far away from Earth in its orbit.
Yes, that's right. At its closest point, what we call the perigee, the rocket is about 330 kilometers. That's where we are now. And at the farthest point, it's just over 750 kilometers. And it takes about 37 minutes to climb to this highest point. And once we get there, we will switch on the engine again to reach the targeted orbit.
He's telling us that the propulsion's normal, everything's going normally according to plan. Another question from Ariane, who has asked, why are there so many armed forces for this launch?
Well, in fact, the Guiana Space Center is Europe's spaceport, and as such, it is a strategic facility for Europe. Therefore, the center is constantly protected by the French Foreign Legion and the armed forces. But for today's launch, considering the nature of our passenger, there are additional forces that have been deployed to assure the security of the launch and the satellite. For example, we had some Rafale fighter jets that have been deployed around the launch site.
Yep, the Rafale, or Rafale in French, the French fighter jets, which I think Rafale means gust of wind in English.
That's right.
Yep. So, 22 minutes and 20 seconds. We are at an altitude of 328 kilometers and flying just under 8 kilometers per second. We are coasting without the engine right now. The teams at the French Space Agency, CNES, are eagerly waiting to take control of their satellite. And their mission control room, we saw them earlier, it's in Toulouse in France. Let's go over now to the project manager, Paul Arberet, and the team.
Bonjour à tous, beaucoup d'émotions ici et aussi de concentration en salle de contrôle principale que vous découvrez derrière moi, où se trouvent réunis les experts.
Good afternoon, everyone. We're all very focused here in the main control room that you can discover behind me, where our experts are together. They have designed the CSO system. So we have experts from the CNES, from Airbus, from Thales Arianespace. And for several weeks, they are going to steer the operations, ensure that all of the equipment is working properly in order to carry out this mission. So let me give you a little bit of an explanation as to what will take place for this satellite as soon as we detect that it's been separated from the launcher. It's going to start an automated sequence. First of all, it's going to deploy its solar panels. It's going to carry out several maneuvers so that its solar panels are headed towards the sun and that its antennas are headed towards the ground, to keep in touch with experts here in Toulouse. So I've asked Jean-René and Camille Souchet to join me so that they can tell you a little bit more about their job. Jean-René, you're an expert. You're an avionics and onboarded electronics architect. So you are going to follow all of the equipment and ensure that it's all working properly. And if it's not, you will come up with a diagnostic so that we can react accordingly. Once the satellite is in orbit, What do you exactly do to be able to react? We have many resources on board the satellite, as well as in the room with all of our experts, so whether they're CNES, Airbus, or TAS. And if we see that something went amiss, we are going to carry out a diagnosis in order to to find out a backup system, so we can also change the equipment if needed, because our satellite has a lot of redundant equipment, so we can change the settings at any time if needed. So Jean-Renaud, you've been doing this job for over 30 years. You've done more than 10 launches. So how has your job evolved over the years? So it's always a very instructive job. Each launch teaches us a lot because there's never two same launches. There's a wide diversity of context, equipment. We meet very different people also during launch campaigns, and it's always very informative, and I like sharing this with my colleagues, my counterparts in other companies in the industry. We are a big team, and we work together hand in hand. And now I turn to you, Camille. You don't have quite as much experience as Jean-Renaud, but still quite a wealth of experience. You are a command control architect, so what is that? So a command control architect is the person launching the activities on board. They're in touch with the engineers, onboard engineers in the next building. We send the measures from the satellite. I get the authorizations from different experts, and I ensure that they stay aware of the operations and how they're running on the satellite. So can you explain how you ensure that you always get these operations right? So there's a procedure for each activity. Everything is validated and tested on a simulator. We also have several rehearsals. We simulate breakdowns, so we are prepared to react to any situation. So before becoming a member of the CSO team, you were working on the SWAT civil system. It's the first time you work for a defense system. Is it very different in the way you work? There are many more similarities than differences. Each satellite is different, but the operations and the way things are run are similar, so I knew how this worked, and I also got a lot of help from my colleagues who shared their knowledge with me. Well, thank you both. I'm going to let you go back downstairs
Wonderful
to your
to hear
control
from
room.
the teams
And we
there at
are
the Mission
all
Control
eagerly
Center
awaiting
in Toulouse. Really interesting to
Accord.
hear what they do, and we are wishing you all the very, very best now as you get closer to taking on your new satellite. So we are coasting without the engine. We are going to take a break now for about 20 minutes, and we'll see you back here at 17:15 p.m. Universal Time. That is 18:15 in Paris, and we're going to leave you with a short film about Lego, because you may have noticed that David and I have a Lego model of Ariane 6 in our studio. Basically, Lego have a website. It's called Lego Ideas, and it's for people who have ideas for new Lego sets. And somebody's come up with an idea for a Lego set for Ariane 6. And if we get enough votes, it'll get turned into a real set. How many votes have we got so far, David?
Yes, right now we're about 6,200 votes, and we need to get to 10,000. So make sure you go and vote to make Ariane 6 Lego a reality.
Yeah, absolutely. Go on the Lego Ideas website. We will also have a QR code at the end. We're going to show you a little film, and there will be a QR code at the end that you can scan, so get your camera ready. And don't worry if you miss it, because we're going to put the film on again at the end after the break. So, yeah, let's get going. Let's get voting. This, of course, is a prototype, and I have to admit that we have already had separation of the boosters, because one of them did fall off earlier when we were rehearsing, but we've managed to put them back together again. So it's a prototype, and it will look a bit different. But watch out now for the film, Lego Ideas. Please get voting.